Okay, so for 56, they want you to, for part A, they want you to verify that these two are factors of f of x. So to do that, remember that the factor x minus a means that a for this first one is negative 2. So when you set it up for synthetic division, we don't write 2, but we write negative 2. So I have the list of coefficients in order from highest degree to lowest degree term. And so remember, you bring down the 8, you multiply the 8 with a negative 2 and put the answer right here. Then we combine the negative 14, negative 16, you get negative 30. And then negative 30 times negative 2 is 60. Combine the negative 71 with 60, you get negative 11. Multiply negative 11 by negative 2, you get 22. When you combine these two, you get 12. And then 12 times negative 2 is negative 24. So the remainder is 0. So x plus 2 is a factor. To verify the other one, I'm going to use, rather than use the original polynomial coefficients, I'm going to use the reduced one. Okay? Because what I'm doing, as I do each synthetic division and find a factor, I've reduced the original one to, the original factor to this. And it's better to use the reduced one. Okay, so 8 minus 30, 11, and 12. Okay, bring down the 8, then you multiply, you get 32, you combine, you get 2, multiply, you get 8, combine, you get negative 3, multiply, you get negative 12, and then 0. And so this means that, well, the remainder 0 means that x minus 4 is a factor. So this means that the remaining polynomial, the remaining factor is 8x squared plus 2x minus 3. So for part B, they want you to find the remaining factors. So I'm going to, because it's a quadratic, I'm going to do the multiplying the x squared with the constant. You get negative 24x squared. And so I'm going to use the 2 by 2 where I put the leading coefficient here. And then for negative 24, I know that 6 times negative 4 combines to give you 2 and multiplies to give you negative 24. So I'm going to put a 6 here and a negative 4 here, and then in the last box we put the constant. Okay, so now probably not going to fit it here. Let me rewrite it. Okay, so greatest common factor out of these two here is 2. Then 2 times something gives you 4. 8. That would be 4. 2 times something gives you 6, that would be 3, and 4 times something gives you negative 4, that would be negative 1. And you always verify that negative 1 times 3 gives you that number right there, and it does. So what this means is that you factored it correctly. So the other factors would be 4x plus 3 and 2x minus 1. For part C, they want you to write f of x in factored form, complete factorization. So part C would be f of x equals x plus 2, x minus 4, 4x plus 3, and 2x minus 1. Parentheses right there. For part D, they want you to find the zeros. So the zeros would be negative 2, 4, negative 3/4, and 1/2. Because remember, what we're doing is we're setting each of these factors equal to 0 and solving for x. Okay, that's your 0. That's where the x crosses the x-axis. I mean, the function crosses the x-axis. Alright, for 61, they want you to list the possible rational zeros and then to find the rational zeros. So we start off by finding all the factors of the constant, which are the p factors. So that would be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 9, and plus or minus 45. Then you go find the Q factors, which are the factors of the leading coefficient. So that'd be plus or minus 1 and plus or minus 2. Then we have to find the ratio P over Q, and this P over Q is the one that gives us all the possible rational zeros for this polynomial, for any polynomial. So I'm going to take each of these numbers over each of these numbers. Okay, so I'll start off with 1, the one on the P. So I'm just going to write plus or minus once, because since each of them are plus or minus, your final result will be plus or minus. So I'll just put plus or minus 1 over 1, plus or minus 1 over 2. Then I move on to the next p-value, which is 3. So plus or minus 3 over 1, plus or minus 3 over 2. Okay, then I move on to the next one, which is 5. Plus or minus 5 over 1, plus or minus 5 over 2. Then the next one, 15, plus or minus 15 over 1, plus or minus 15 over 2. Then the 9. I usually write them in order. It's not a big deal though. Plus or minus 9 over 2. And then plus or minus 45 over 1, and plus or minus 45 over 2. So we've got 2, 4, 6, 8, 10, 12 numbers, but each of them are plus or minus, so that makes it 24. So there are 24 possible rational zeros for this polynomial. So remember, from all the numbers on the number line, these are the only 24 numbers that could be rational zeros. So now they want you to find them. What I'll do is I'll use technology to help us out. So I've graphed this on a graphing calculator, and I also have it on have the table for the function, and I'll show it to you right now. Alright, so here I have the table for this polynomial and the graph side by side, and as you can see, by looking at the table, I've identified a few of the zeros, because I know there are 4 maximum zeros, and how I know there are 4 maximum is because that's the degree of the polynomial. So 4 maximum real zeros. Okay, so I've got 1 right there, and then I've got the highlighted one right there, the 3, and the 5. So I know those are zeros. Okay, and they're all on our list. If you notice, I've got negative 1 right here, positive 3 right here, positive 5 right here. Okay, and the intermediate value theorem tells us that between 1 and 2 I have another 0. How do I know that? Remember that wherever there's a sign change, so from negative 16 to positive 9 right here, the graph has to cross through the x-axis. So that would be between 1 and 2. So that would be 1.5, or, you know, because I'm looking at the list here, the more logical one would be 1.5 if it's a rational zero. It could be that it's not a rational zero. Okay, so to be on the safe side, I'll start off with the ones that I know are zeros. Okay, the ones that are on the table. If you look at the graph, you'll notice that at negative 1, it crosses the x-axis, right? At 3, 0, 1, 2, 3, it crosses the x-axis. At 5, 0, it crosses the x-axis. And then right here, crosses the x-axis. It could be 1.5, but we're not sure yet, because if it's irrational, it would not be on our list. So like I said earlier, let's start off with the ones we know, the zeros that we know for sure. So negative 1, and then so I write down the coefficients. So we bring down the 2, multiply 2 times negative 1, combine, you get negative 19, multiply, you get 19, that gives you 54, multiply, you get negative 54, and so that gives you negative 45. When you multiply, you get positive 45, and that gives you 0. Okay? It's 45. And so now I'm going to use 3. I'm just going to go through the list of the ones I know for sure work, right? I'll use 3. I'm just going down the list of the ones I circled in pink. So I'll do 3. And remember, use the reduced polynomial. Okay, so I'm going to use this one instead of this one. So 2, negative 19, 54, negative 45. So bring down the 2, multiply, you get 6, then that gives you negative 13, that gives you negative 39, and then that's 15, so that gives you 45 and 0. Okay, so I can use 5 since I know it's a 0, or I can use quadratic formula or factoring. Since I know 5 is a 0, let's go ahead and use 5. So then I'm going to use 2, negative 13, and 15. So bring down the 2, I get 10, negative 3, I get negative 15, and 0. Okay, so now what do these numbers mean? These mean 2x minus 3. Okay, because it's always x to the 0, to 0, and x to the first power. So it goes up, as you go to the left, it goes up by 1 power. So here's the factor, 2x minus 3. You set it equal to 0, and you get 2x equals 3, and then x equals 3 halves. So it was 3 halves, again, but we weren't sure because it could have been an irrational 0, so that's why I started with the ones that I knew for sure were zeros. Okay? Alright, so for 67 through 70, we're going to do B, C, D. We're skipping A, Descartes' rule of signs. I'll go over it with you guys on Monday, but it's not as useful as it was when we didn't, before, like when we didn't have graphing calculators. Back then it was very useful, but now it's not as useful as it used to be. But I'll still go over it with you. So for now we're skipping it. So B, it says list all possible rational zeros. So we know that it's plus minus 1, plus minus 2, plus minus 4. And then for 1, it's just plus minus 1. Well, that makes P over Q pretty much this list right here, because we're dividing everything by 1, right? Q is 1. So it's just plus minus 1, plus minus 2, plus minus 4. So those are the 6 numbers that are possible rational zeros for this polynomial. And then for C, it says use a graphing utility. For this particular one, actually, because it's 4 terms, and it's a cubic that's 4 terms, every time I come across one like that, I always just try factoring it like this. And if it works, great. If it doesn't, then I'll go and use the synthetic division and all that other stuff. But I try this first. So I put x cubed, I put it in order, like this. And then just factor, greatest common factor here is x squared. And then x squared times something gives you x cubed, that would be x. X squared times something gives you x squared, that would be 1. And then x times something gives you negative 4x, that would be negative 4. Oops, negative, right. And so you check, is 1 times negative 4 negative 4? The answer is yes. So your factors are right here. X squared minus 4 times x plus 1. Oh, what is it writing? Plus 1. And so I could factor this one further. X plus 2, x minus 2, and x plus 1 is there. So these 3 are the factors for the polynomial. So the zeros are negative plus or minus 2, right, for the first 2, and then negative 1.